In this video, I'm going to go over the 5.0 Chemistry Final Exam Practice Quiz that covers equilibrium. So this first question here, it says, what effect does a catalyst have on a chemical reaction? And it doesn't matter if you think about this from an exo or endothermic point of view, because you will get the same answer. So when we have a reaction diagram like this, we have enthalpy on the y-axis, reaction progress on the x-axis, and we can just draw this in here, and this is what we end up getting for an exothermic reaction. So for this reaction to occur, the reactants have to get enough energy to get up over this hump, basically, to get to the activation energy, the energy of the activated complex. And then once that happens, the reaction will go very quick. So this is kind of like if you're striking a match. You rub the match on that friction pad, and that is supplying that energy it needs to get to this activated complex here. Now, if you add a catalyst, really all it does is lower the activation energy, and what you're doing is forming a completely different activated complex that has less energy associated with it. It's not going to change the concentration of the reactants or products. It's just going to make the reaction go quicker because the activated complex now with the catalyst has less energy associated with it than a non-catalyzed pathway. So when we look at this, it increases the reaction rate, right? It makes the reaction rate go faster, and it lowers the activation energy. It does not do anything to the concentration of the reactants or the products. This next question, and this is a Le Chatelier's question. If you have this reaction and you remove H2O gas, what will happen to the concentration of nitrogen monoxide? So in this example, when a reaction is in equilibrium, if you do impose any kind of stress on that system, the system is going to try to minimize that stress. Really what it's saying is it's going to try and fix whatever change you made. So if you remove some H2O gas, and I'm going to put a circle around that because that's the initial stress, it's going to try to minimize that change. So this is like saying it's going to try and make back some of that H2O. Now it's never able to make all of it back. So you're always going to be at a net loss of H2O at this point, but it's just going to try and minimize the change. So if you take away one of the chemicals, the reaction equilibrium is going to shift to that side. That's how it tries to remake it. So if you take away a product, equilibrium is going to shift to the product side, and the way it makes more product is by using up some of the reactants. These get consumed or these get sacrificed to make the products. So whatever side this is pointing to the reaction equilibrium shift, that side is going to increase. So it's asking about nitrogen monoxide, so that one ends up increasing. Just remember, if you take away something, equilibrium shifts to the same side. Now the next one is talking about the same reaction, but it's saying if you increase the temperature. So what we have to do is look at this temperature, this enthalpy, I guess I should say. It's a negative number, which means that this is a exothermic reaction. It's telling us that heat is a product. So if you're going to write the thermochemical equation, you would just have heat on the product side. Now this is saying you increase the temperature. So we are increasing the heat energy. So we just added something to the product side. Now if you add something, the reaction is going to try to minimize that change. It's going to try to consume some of this excess heat, and it's going to shift to the opposite side, right? So now if you add something, it shifts to the opposite side. The way it's going to try to get rid of this excess heat, it's going to sacrifice some of these other products because they will react with that heat. So their concentration is going to go down a little bit, and it's shifting to the reactant side, so the reactant side is going to go up. So by adding more product, you are making the products react more with each other, and when they react more with each other, you're remaking reactant. So it's going to shift to the left, to the reactant side. If you increase the pressure of this reaction. So when you see pressure, first thing you want to do is make sure that it is a mixture of gases, and this one is, because if they're not gases, changing the pressure doesn't have any impact on it. And the other thing you want to look at now are the coefficients. There's a total of 9 moles of gas on the left and a total of 10 moles of gas on the right. And the temperature is not really going to have any impact on this right now. So if you increase the pressure, that's saying you're increasing the number of collisions. Well, the reaction, if you can think about a reaction as wanting something, it doesn't want those extra collisions. So it's going to try to minimize that. And the way it's going to try to reduce the collisions to put them back to where it was when it was in its original equilibrium, it's going to shift to the side with fewer molecules. That's how it's going to minimize the increased collisions that you somehow caused. So this is going to shift to the reactant side. So increasing pressure means it shifts to the side with the least gas moles. And if you decrease the pressure, it would be the opposite. It would switch to the side with more moles of gas. So since we increase collisions, it shifts to the side that would have fewer collisions, which is 9 compared to 10. And this one's pretty straightforward. Activation energy of the reverse reaction. So if it's the reverse reaction, that means you're starting off where we usually think of as the products. So if you want to figure out activation energy, you just have to figure out the difference between here and the top of the curve. So it's 100 kilojoules up to 250. So that difference is 150 kilojoules. Pretty straightforward there. Just pay attention because it says reverse reaction. If it was forward reaction, it would be going from 50 up to 250. But this was reverse.